Hello everyone. Today we're going to talk about 0-1 knapsack problem and using the branch and bound and best first search approach to solve that. In the previous video we learned about solving the 0-1 knapsack problem using the branch and bound approach and depth first, like the breadth first approach. So in the breadth first approach, we were going level by level, okay, and row by row in the tree that we have to find the solution. Instead, in the best first search, okay, based on the bound that we are founding, for each node, okay, if that node has the better bound, okay, let's say if our bound is trying to maximum, and this is the case in the 0-1 knapsack problem, that we are trying to maximize our bound, okay, a profit. So the one that has the highest profit will be expanded first, and then we are going to expand the rest of the nodes based on their based on their bounds. So instead of using just a queue, we are using a priority queue. So anytime that we have a node, okay, we are using a priority queue to insert the node that has the better promising value, or a better or a maximum or higher bound. So here, as you see, also I have written the things that we need to calculate the bound. Okay, in the previous video we showed you some example of a knapsack problem with 4 items and all of their the values and their weights. Okay, and then a few moments I'm going to show you how we can use these ones. So these are the formulas: total W, total weight, and also we have the bound. So the total weight is the weight that we had before until we reach this the node that we are. And then the j equal to I plus 1, I forgot to add this one here, so that is wj. So we are going from what's the weight from I equal plus 1 to k minus 1. And as again we said that I is the level that we are already in, or this the level, the item that we already picked on. So let's say that I is equal to 2. It means that, for example, we have picked or not picked the item number 1 and 2. So now it's for continuing, picking or not picking item 3 and 4. And the k was the item that if we are at that item to our bag, then the weight gonna be more than the total weight, that is the w that we have here. So that's why we have k minus 1, and that's why we have I plus 1, because we are going to start from the next item, not the item that we already included. So this WE is all the weights up to level I. So that's going to be our total weight. Then we're going to have the bound that says that how much going to be the maximum band, okay, on this on any node. So that's going to be the profit that we gained so far. Okay, so you can see that this WE as the weight that we have so far, and this profit is the profit that we gained so far by picking some of the items. And similar to the concept that we talk about the WJ, we have also the PJ. So P subscript J, and J goes from I plus 1 to K minus 1. Again, the same concept with why we are choosing from I plus 1 to K minus 1. And at the end, we have the total, the maximum weight that can be gained, that is W, minus the total weight that we calculated, multiplied by the ratio of the value to the weight of the item that we cannot pick. So that's going to be our bound. Now let's go and based on our example, I'm not going to calculate the values here, because on the previous video we calculated some of the values. So I'm going to show you the values and see that how the best first search and the branch and bound works on the 0-1 knapsack problem. Okay, now we have this example here again with 4 items, and the total weight that can be gained is 16. That can be picked is 16, and also the items are sorted based on their ratio of the value to the weight. So here is the order. So I'm not going to calculate the like the bound again. Okay, if you want like to see that how we are calculating the bound, okay, you can back to see the like the formula, and also you can watch our previous video that we calculated the bounds for some of the nodes. But here we have the bound that is calculated equal to 115 for the first node. That is when we haven't had any item yet. And as you remember, the first value here was the total weight that we had so far. Okay, this W is the capital one, and let's write it as the WE. That is what we gained so far. And this 0 is the profit. Okay, so I'm gonna just show it as P. Okay, so just show it as P, and this 115 is bound, so I'm just gonna write B. Now, because we don't have any other node in this tree, so we are inserting this node into the queue that we have. So then we are dequeuing or removing this node from the priority queue. Okay, again, this is a priority queue because this is the best search, best first search. We are gonna like to go and expand the node that is promising and has the higher bound. So here, if we expand this node, we'll have on the right side when we are including item 1 and we are not including item 1. So if you're including item 1, again, I'm not going to go and calculate these things, but we'll have, let's smaller. This is going to give me the I think I just, yeah, that's right. It also put the first one to be the profit and the second one be the weight and the last one be the bound. Okay, so let's keep this way. And so the first one is the profit that is going to be $40. The weight going to be 2, and we'll have still the bound that is equal to 115. And as you can see, I mean, you can calculate that why it's 115. And here I wrote the K equal to 3 and 3 with the other color because, you know, the K is when, again, we said that when our the weight that we are gonna, the maximum is gonna, the weight that we can, the total weight gonna exceed the maximum weight. So if I pick the number item 1, number 1 and 2 together, the weight gonna be 7. If I include number 3 also, there's going to be 17, that is greater than 16. So that's why I calculated K is equal to 3. But I is equal to 0 because I'm at level 0. Here, I becomes 1. Okay, I becomes 1. And again, K will be equal to 3. Okay, because I already have the total weight of 2. And the item that I can gain, or let's see, that's gonna be K for this one is gonna be 4. Okay, for this one, and for this one K is still be equal to number 3. In this case, why K is equal to 4? Because again, we are not including item number 1, so the weight that we already picked is 0. So I can pick item number 2 that has item 5 weight, and item number 3 that has 10 together is going to be 15. But if I include item number 4, then it's going to be more than like 16. So for this part of for this node, K is equal to 4. But both has the I equal to 1. So it means that you are at level 1. Okay, so let's also write here that I also is equal to 1 for this node. So just that was for like just remind you of that how we work that. If also you continue like you're calculating the value for here, this is gonna be 0. Okay, the profit is gonna be 0, the weight is gonna be 0, and the maximum bound gonna be 82. And it's obvious that why the profit and the weight are 0. Okay, because at first we started with empty bag, then we came here and we didn't pick the item number 1. So it's obvious that there is no profit and there is no item in the bag, so that weighs something. So that's the first 2 items are 0, and the maximum bound are gonna be 82. Now if you look at these 2 nodes, okay, we are gonna like do the best search, best first search. So between the node that says that include item number 1 that has the bound of 115 and the node that doesn't include item number 1, that has the bound 82, we are picking the one that is more promising. And here in this case is when we are including item number 1, because it has the item the bound of 115. It doesn't mean that it's gonna like give us exactly like it's gonna be the solution. But for now, okay, because we are gonna see that we are gonna like to try to like the node and expand the node, that for now at least gives us the better promising value. Okay, so that's why we are going expanding this one, and for now just not expanding the other one. Okay, again, it might be the case that okay, this node one, when we're going number 1, it might not give us like at the end the value that we are looking for, and we may have to expand the node that doesn't include item number 1. So if we continue, and here let's say that I including number item 2, okay, and not including item number 2, then we'll have this value. So it's gonna be 70 here. So we are including item number 2. So together we're going 70, because item number 1 has 40, item number 2 has 30. So together the total profit gonna be 70 so far. The weight gonna be 7. That is obvious because 2 and 5, the item number and white item number is 7, and then still the bound will stay 150. So that's for this node, and now we are gonna expand the other node of this one here. That gives me not including item number 2, so there is no change in profit. This is 40, and then I have the weight is equal to 2 because I haven't included item number 2, so I only have item number 1 in the bag, and now the bound decreases to 98. Okay, so and again it's just using the formula to see that how we got the value 98. So now if we continue between these two nodes that we have, between the nodes that we have here, so we have 150 here, and we have 98 here, and we have 82. So again, using the best first approach, okay, so we are going to expand this node that has the higher band, that is 150. So if we go, okay, here, it means that including item number 3 or not including item number 3, okay. If we include item number 3, okay, then our weight, like the total value profit is going to be 120, but our weight going to be 17, and the bound will decrease to 0. Okay, so and now this node is non-promising, and because the total weight is now more than 16, so now this node goes out of the selection. So this node is not promising anymore. And now let's see when we are not including item number 3. That's gonna be our maximum still is gonna be 70. Okay, because we are not including item number 3. So 40 and 30 of item number 1 and 2 is gonna be 70. The total weight is 7, and the bound also decreases here, equal to 80. So now look at the numbers that we have here. Which one is more promising? We have 82 here. We have 82 here. We have this 98, and we have this one that has 80. So between these 3 nodes, again, we are going to choose the one that is more promising than this node when we are not including item number 2. So okay, let's. I'm going to like. Show next how we can expand also these nodes. Okay, as we said, between these 3 nodes that we have that has the bound of 82, 98, and 80, this one has the higher band. Okay, so we are going to like to expand that node for now. So here, if we expand it, so it means that including item number 3 or not including item number 3. Okay, so if we include that item number 3, then we're gonna have the profit of 90 and the weight gonna be 12 and our bound will be 98. Okay, so here as you see now, we are not gonna go and expand like the two other nodes that we have here, that is this one 82 and 80, okay, because their bound is 80 and 82, but we found a node, okay, that is its profit is now more than the bound of the other two, so we are not expanding the other two node anymore. So we are removing this from the queue, and also we are not expanding this one, so there's gonna be like eliminated from our search. Now we have this one is 98, and now also we need to expand the other node and see that which one is more promising. So if we do not include number 3, so we're gonna have 40, and we are gonna have 2 as the weight and 50 as the promising. So here, as you see here, if we include only item number 1 and not include item number 2 in our bag, not include item number 3, okay, so the total profit that we gain, okay, is 40 so far. So we gained 40 so far, and the weight is definitely is equal to 2 because we only picked item number 1 and none of the items 2 and 3, and the only items that remain is item number 4 that's going to be expanded after. But as you see now, the bound for this node is equal to 50, and we already have this node here that is giving us the profit equal to 90. So this node also not gonna be expanded. And now we are gonna like to expand the node that the only node that is remained, that is this node that is promising so far. So we will have this one here. So if I include item number 4 or not including item number 4, then I'm gonna have these values here. So it's gonna be 100, it's gonna be the total profit, but the weight gonna be 17, and then the bound is gonna be 0. And because now the total weight that I gain is more than 16, that was my my limitation, so this node also becomes non-promising. So I'm removing that also that node. And now I'm gonna expand the other node, that is when I'm not including item number 4. So when I'm not including item number 4, then I will have here 90, then 12, then 90 that I have here. And as you see here, the gain are same, okay, but the bound of this, like the one that I had here, this one is higher, okay. So this node is my value. So it means that when I pick item number 1, not picking item number 2, and picking item number 3. So item number 1 has the total, like the profit of 40, and item number 3 had the profit of 50. So the weight for this one was equal to 2, and for this one was equal to 10. So together, okay, so that's going to be my total profit, and it's going to be the total weight that I am picking. So that's how the branch and bound, okay, works for like the 0-1 knapsack problem. But instead of like the breadth first approach, like the search on the tree, we use the best first search to prune the tree. Okay, now let's take a look at the best first branch and bound algorithm for solving the 0-1 knapsack problem. So here, before starting the like the tree, everything is equal to 0. We don't have any level. Then the weight is equal to 0. It means that we haven't picked any item. With this also the value is equal to 0, and the bound is definitely also equal to 0. Now we are gonna like calculate the maximum bound, okay, that what we can gain, okay, for the root when with all items that we have. Then so it's gonna give us the v that we here in this case is the root that in our example was giving us the number 150. Then and again, this is a priority queue, so this PQ is a priority queue. And this node is like the here is the promising node. This is the root here. And while the our priority queue is not empty, okay, because we're going to make sure that we are expanding all the promising node that are going to be better than what we have so far. So while the priority is not empty, then we are removing that. So this means that the first node. Then because the max value is less than 0, is less than now the new bound that we are already calculated was equal to 115. So we are going to the next level that was including the item. So you can see here, for example, let's say that we have the item number 1. So we're increasing level, and the weight gonna be the weight of the item at item 1, and also its value gonna be the value plus the value equal to 1, a value of the item number 1. Now after having this weight and the value, now we are going to make sure that the weight, okay, is going to be less than the total weight that we can gain, okay, because we don't want to insert a node or expand a node that is not non-promising. So that's a check for that. And if the value that we are calculated is larger than the max value, do you remember that, for example, the first node root has the max value of 0, okay, but now we are increasing to 40. Now we have 40. So we are changing the maximum value to 40, so we can gain now up to $40. Then also we are calculating the bound for this node. Okay, so you're going to see that what's going to be the maximum bound. Then again, we are checking if the maximum value, okay, that now we have so far is less than the bound. So on the first node, the maximum value was equal to 40, but the bound was equal to 150. So it means that we still can continue, okay? That's not the stop point for us. We are not stopping after like picking only item number 1 with $40 gain, okay? So because the maximum value again is less than the bound, we're inserting that node and we're going to expand it to probably gain more profit. This part is when we are not including this item, okay? So if we are not including this item, okay, the weight and the value, okay, definitely doesn't have any changes, okay, we're not including that one. But now we are calculating the bound again. Calculating the bound again without, okay, having this node, okay, included. Then again, we are checking if the maximum value is less than, okay, less than the bound of this new node, like the node that we found this bound, okay, it is, then we are gonna insert it into our priority queue. And because this is a priority queue, insertion here means that if this one is like the value of this bound here, this node is gonna be is larger than this one, greater than this one, so it's gonna expand that node first. Okay, so it's not like the breadth first that is the like if you are in queuing and then everything that you're adding goes to the end of the queue. So it's a priority queue. So if it has a better like the bound, okay, it's gonna go at the very end of the queue. So at the end, we are returning the max value that we gained. So in our example that we provided was value 90. That was the when we are picking item number 1 and item number 3, and the bound for that example was, and the maximum bound was equal to 90. So that's like the algorithm and one example for the best first branch and bound algorithm for solving the 0-1 knapsack problem.